Okay, so it's another time when we have to keep on with our discussion about the calculus and the engineering mathematics. So I didn't write the subject or the module. So the module is called the calculus and the engineering mathematics. And the engineering mathematics. So if the first time to meet me, my name is Olenjolai. I would like to take this opportunity to welcome you into a sequence of lectures about calculus and engineering mathematics. I have some physical students who have joined me in this class, and I will appreciate them who have come physically. But I know that I have a number of students who will join me online by using the power of the internet. So I would like to say that the concept that we are going to learn, we just have the fundamental skills in ordinary diploma and advanced secondary education. But the concept or the phenomena of, let's say, Laplace transform, it's new. We didn't teach you that concept in OD, and we did not teach you that concept in A level. So it's a new concept for students who have a background of ordinary diploma and those students who have backgrounds of advanced secondary education. But I want to tell you that calculus is not a difficult subject. Higher engineering mathematics is not a difficult subject. It's actually interesting and it's a little bit challenging subject. So if that's the case, I believe that you have been preparing yourself, have a fresh mindset. Take your exercise book, take your pen, take your pencil, have your scientific calculator, and also have your exercise book where you have to take a note. One thing which I want to tell you in advance, we are very serious and we are going to deliver to you a serious contents that actually will transform your level of understanding. It may be you are thinking about test 1 or test 2 or final exam or assignments of calculus. I want to tell you that yeah, it's a good thought to think about that. But I want to tell you that I will be giving you some skills and I will teach you a lot of mathematical techniques which actually simplify any mathematical problems or calculus problems that you are going to encounter. At the National Institute of Technology, some of the students are studying the module called calculus, and also others are studying the module that called engineering mathematics. So if you are in an engineering field or you wish to be an engineer, I want to tell you that it's a good time if you take this course and you take this content. Another thing that before we start our today's lecture, in case you have a question, don't hesitate to ask it. And one thing which I want to tell you in advance, Olenjolai does not know everything about calculus. I just know a little, but I have a responsibility to teach others. And also I don't know everything about engineering mathematics. I just know a little, but I have a responsibility to teach others. But I want to tell you that these are the models that I like for the rest of my life. I usually learn new concepts. So I don't know about you. Maybe you're an engineer, you're an electrical engineer, you're a mechanical engineer. But I want to tell you that in undergraduate level, we apply this concept. In master degree level, we apply this concept to solve real life problems. And even in doctor of philosophy studies, which is called the PhD, you will encounter, PhD of engineering or of science, you'll encounter this concept in another shape. Okay? So let me appreciate some physical students and then start the lecture, because I don't want to talk a lot, while mathematics can talk a lot about itself. How are you, electrical engineering students? You are fine. Are you ready for lecture 2 of Laplace transform? Yeah. Well, myself also, I'm ready for that. We have our online school that's called Tanzania, Online Institute of Technology. This is the departments of Fire Engineering and Scientific Mathematics. And modules is called the Calculus and Engineering, Mathematics. This is chapter 2, Laplace transform. And this is lecture 2, Laplace transform of hyperbolic and trigonometric function. Class A, Laplace transform. Class A, Laplace transform. This is the second topic according to the Dar es Salaam Institute of Technology curriculum. And Class A, Laplace transforms of hyperbolic and trigonometric function. Whenever you say or you pronounce these terms will be written in your mind, right? Repeat it. Say Laplace transforms of hyperbolic function and the trigonometric functions. If you don't say, you will end on writing on the paper of your exercise book and then you leave it there until one day or 2 days you will spend the whole night to cram Laplace transform of hyperbolic function. Well, let us start with quick review. Let us start with quick review of lecture 1. In lecture 1 of Laplace transform, first of all, we taught you definition of Laplace transform. And we taught you a literal definition and mathematical definition. So the mathematical definition of Laplace transform is given as Laplace transform of the function which is f of t. This is equal to a function f of s. This one is equal to integral from 0 to infinity e power negative st. Then we have f of t dt. So this is the general formula of Laplace transform. Okay? It's a general formula of Laplace transform. We'll recall this formula in a number of lectures. So stop writing, students. I will teach you in a different style. Stop writing. Say Laplace transform. L standing for Laplace transform. Say again, Laplace transform of f of t is equal to f of s is equal to integral of e power negative st f of t dt from 0 to infinity. Remember this formula. So, remember that, listen. On the right hand side, we have capital F. In the integral sign, we have lowercase f. Don't confuse that. Simply, we say that we may write. Do you know the meanings of this one? Let me just see, put in this style. So this is the one form of the formula, or another form, we can write f of s is equal to integral from 0 to infinity, e power negative st, then f of t dt. So this is another form of our Laplace transform. We just changed on right hand side. Okay? And then in lecture 1, we taught you about the Laplace transform of standard function. Laplace transforms of standard functions. Say Laplace transform of standard function. And the first standard function is called the Laplace transform of a constant. A constant is just a number. And this constant we can call TA. So we derive that Laplace transforms of A, this is equal to 1 over A. So this is the formula. So where A is any constant, whether it's positive integer or negative integer or a decimal number or a fraction. Okay? Then after that, I told you about Laplace transforms of exponential function. Say exponential function. So I told you that how can we find Laplace transform of e power at? Stop writing. Laplace transforms of e power at. Say Laplace transforms of e power at. This one is given as 1 over s minus a. In case you forgot how to derive these formulas and examples, you have to refer lecture 1 in our official YouTube channel that's called Tanzania Online Institute of Technology. Right? We have created a special playlist called the Laplace transform. Then we taught you that, and we showed you by derivation, Laplace transforms of e power negative at is equal to 1 over s plus a. This is just a quick review. So look please. The difference between this exponential function and this one, hello. For this case, we have e power positive at. For this case, we have e power negative at. Laplace transforms of e power positive at is equal to 1 over s minus a. Right? Laplace transform of e power negative at is equal to 1 over s plus a. So the difference, So the difference is the sign of the function. Here we have positive. Here we have negative. Right? So we change the sign behind a. Then also we change the sign of denominator. For this case you have s minus a. For this case you are going to have s plus a. So whenever you have a negative function, we have addition. If you have a positive exponential function, we have subtraction. That's all. Class, are we together? Yeah. So that is what we discussed in lecture 1. We discussed a lot, but that is a summary, the overview, right? The high level of what we've discussed. Okay? Now, let us focus on lecture 2. Tell your neighbor we are in lecture 2. Say we are in lecture 2. So in lecture 2, let us focus on what? Laplace transform of hyperbolic functions. Laplace transforms of hyperbolic function. Say Laplace transform for hyperbolic function. So we say that in mathematics there are 60 hyperbolic functions. So in mathematics there are 60 hyperbolic functions. But in Laplace transform, we will discuss or we'll learn the Laplace transform of two functions only. Okay? So in mathematics we have 6 hyperbolic function. Let me mention for you. The first one, we call it sinshi. Say sinshi. The second one is called the konshi. Say konshi. The third one is called the kothi. Say kothi. The first one is called the oti. So the first one is called the sinshi. Say sinshi. Let's say sinshi of x. The second one is called the konshi. Say konshi. Say sinshi konshi. Sinshi konshi. Quickly.
Sinshi konshi. Sinshi konshi.
Huh?
Sinshi konshi. Sinshi konshi.
Number 3, it's koth. Then number 4 is called the sech of x. Then number 5 is called the cosec of x. Then number 6 is called the tangent of x. So these are the 6 hyperbolic functions in mathematics. You will find them. You will make them. So listen. Sinshi corresponding to sine in trigonometrical function. Corresponding. It looks like we deduce the sinshi from sine. Hello, hello, triangle, triangle. Triangle, equilateral triangle. Then the second one is conch. Conch we deduced it from cos. Right? The third function is tangent. Tangent corresponds to tan. The simple way for you to remember them. Right? And then the other one is sech. So sech. Say sech. Sech corresponding to what? Sec of x in trig. The other one is what? Cosec. Cosec corresponds to what? Cosec of x in trig. The other one is called what? Cos. Cos corresponding to what? Cot of x in trig. You learned them and you still remember them. So the good news in Laplace, we have to learn Laplace of transform of sinch and Laplace transforms of conch. That's all. So life is simple. Okay? Okay, class? So number 1. Is that the case? Let us discuss Laplace transform. Laplace transform of sinch. Sinch of AX. Laplace transforms of 40. It's not Laplace transforms of sine. We'll discuss Laplace transform of sine. This is Laplace transforms of 40 of sinch. And I believe that you'll find this function in some problems or some questions in the exam. Okay? So listen carefully. So then we say that the derivation of Laplace transform, remember that the symbol for Laplace transform is L. But let me keep writing Laplace transform until you adapt it, because sometimes you may say the derivation of L of sinchi. Laplace transform. Laplace transform of sinchi of AX. So to derive that, we are going to follow a number of steps. I usually teach every concept in mathematics or in electronics or in electrical engineering by following steps. Engineering is all about a set of procedures. We call them algorithm. It's just like yourself. Even your lifestyle, follow some particular steps. Once you wake up, you pray. Then you take a shower. Then you dress yourself. Can you dress yourself and then you take the shower? No. Okay, so the first step, recall the formula of sinch of AX. Sinch of X, let's say. Sinch of X in mathematics. We used to teach the concepts of a parabolic function to ordinary diploma level and the advanced secondary education students. That's why we ask you to recall. But maybe you forgot. That's why I have to remind you. Can you ask your neighbor, write for me the formula of sinh of x. Write for your neighbor. The good thing that now, this is the active class. Write what you think, what you remember about the formula of sinh of x. Just write. Even if write sinh of x is equal to sinh of x, it's fine. That's what you remember. It's better to check what you remember. So once I remind you, you will never forget. Okay, write for your neighbor, please. Okay, so I think that you have written for your neighbor. Is it? Let us assume. So let us correct your neighbor's work. So he said that sinh of x in mathematics is equal to e power x minus e power negative x over 2. So mark, put a tick to your neighbor's formula, mathematical formula. So look please, stop writing first. In this program, I will teach you that how to learn to try and practice. So before you write, listen, understand, then you write what you understand. You should not write and then you will understand later. No? You have to understand it here. You don't have later time. This is the later. So now we have now and future. So stop writing. So this is the formula that we taught you in OD, and this is the formula that we taught you in A level. Okay? So in case of the college or university level, we are going to change something here in this function. So we are going to have sinh of AX. It's not X. This one, when we change any variable here or any parameter here, it will affect also the powers of this E. So now we are going to have E power AX minus E power negative AX divided by 2. This is what we need in Laplace. Okay? So this is our equation 1. I said stop writing, listen and watch. If this is the equation 1, it's fine. We go for the second step. The second step is we say that apply. Apply what? Laplace. L stand for what? Laplace transform to both sides of equation what? 1. To both sides of equation what? 1. So you are going to apply. So how are you going to apply? Look, we write Laplace transform. We open the curly bracket, just like its formula. Then our function is what? Our function is what, student? Sinh of AX. This is equal to what? Is equal to Laplace transform of what? E power AX minus E power negative AX divided by 2. Are we together? So this is what we are looking for. Okay? Okay? Next is just a simple computation. Here we have 1 over 2, isn't it? We can take it out. Take 1 over 2 out as a constant, 1 over 2. Then Laplace transform of what? Laplace transform of E power AX minus E power negative AX. Are we together? Are we together, class? This one is equal to what? A half. Then Now let us substitute Laplace. Let us open the bracket. Let us say like that once. So if you open a bracket, we are going to have what? Laplace transform of e power ax minus Laplace transform of e power negative ax. Then we close the bracket. Are we together? I did nothing. I just took L multiplied by this. I got this. Then I took L multiplied by this. I got this. Okay? For that case, we say that Laplace transform of what? Of sinh of ax is equal to what? Is equal to a half Laplace transform of e power ax. Right? Now I'm substituting a half. Then minus what? Minus a half Laplace transform of e power negative ax. Are you together? So this is equation 2. Right at that point. If you have a question, you may ask. Okay. So now let us move into the third step. The third step, we say that recall Laplace transform of e power at plus Laplace transforms of e power at is equal to what? I have mentioned it in quick review. Is equal to 1 over s minus a. Let this one to be question 3. Also, recall that Laplace transforms of e power negative at. Why do we recall this? Because in equation 2 we have Laplace transforms of e power ax, Laplace transforms of e power negative ax. While this we know it already. That's why we are recalling them. Okay? So Laplace transforms of e power negative at is equal to what? 1 over s plus a. This is what? Question 4. Okay? Simple like that. Then the fourth step. Substitute equation 4 into equation 4 and equation 3. Into what? Into question 2. I say this, stop, right. Listen first. So if you substitute, what do you have on left hand side? Laplace transform of what? Sinh of a t. This is equal to what? A half. Say a half. Laplace transform of e power negative ax, which is equal to what? 1 over s minus a. Then minus, isn't it? Minus what? A half. 1 over s plus a. Hello? Another emergency? Well, so if that's the case, I say this, stop writing. Please check your neighbor. I say put your pen away. Then a half and a half, this is constant number, right? We can take it out and establish the bracket. So we are going to have 1 over s minus a minus 1 over s plus a. Is it clear? Is it clear? Msaidie huyo jamaa kuchukua peni yake. Chukua peni yake. Chukua tu. Atatoa nyingine mfukoni. Chimbongo. Sema ngoja mkokomoe. This is a half. Then we open bracket. This is fraction. Say fraction. Subtraction of 40 fraction. Tunatoa sehemu. You have to remember fraction. Basic mathematics form 1, secondary education, up to D&D A level, right? In order to do subtraction of fraction, we have to find LCM, lowest common multiple. Ah, so many years ago. You have been good, yeah? So what is our lowest common multiple here? Tell me, what is the lowest common multiple here? S minus A multiplied by S plus A. You are good in mathematics. Tell your neighbor you are good in mathematics. However, that your neighbor does not trust himself or herself. So LCM, simply, if you have forgotten, let us use simple fraction. If we ask you to take the 3 over 4 minus 5 over 12, we used to find the lowest common multiple. For this case, the lowest common multiple is 4, 12. 12. You see that? You are good in mathematics. Right? And then next, we take 12 over 4. What do you get? 3. You take 3 times 3. What do you get? 9. Minus 12 over 12. 1 times 5. Minus 5. That's all. 9 minus 5? 4. 4 over what? 12. We are going to do the same for this case. Okay? So this is our LCM. We take this LCM divided by S minus A. What do you have? S plus A, right? We take S plus A multiplied by the numerator, which is 1. What do you get? S plus A. Then minus. Okay? Okay? Then take this one divided by S plus A. What do you have? S minus A. S minus A. Are we together? Yes. So if that's the case, you have a half. And then we have S minus A and we have S plus A. Open the bracket. We have what? S plus A minus S plus A. Are we together? Yes. Negative times positive is negative. Negative times negative is positive. Okay, class? Yes. So you can write quickly. Okay, stop writing. Let us finish, then we write the word. What do you have on left hand side? Laplace transform of 40. Sin of 40 is equal to what? A half. I say stop writing. What do you have in denominator? S minus A multiplied by S plus A. Is this it? Then in numerator, S plus A minus S, yeah? Plus A. Okay. S minus S, 0. A plus A, 2A. So you have a half. In numerator we have 2A. Over what? S minus A, S plus A. Then 2 and 2 cancel. Therefore, sin of 80 is equal to what? A over S minus A, S plus A. Okay? Okay? We have to keep moving. Oh, sorry, Laplace transform of sin of 80. We have to keep moving. So, what do you say? You have to remember about the expansion of factors or linear factors. Let me remind you. In form 2, we told you that if you have x minus 2 multiplied by x minus 3, we can expand. How? X times x, we get it, right? Then x times negative 3, what do you find? 3x, right? Negative 2 times 2x is negative 20. Then negative 2 times negative 6 is positive what? we are going to apply the same concept with these letters. Okay? So if that's the case, here you're going to have A over S times S. S times A. A? A, yes. Negative A times S. Check your neighbor if he or she is multiplying. Negative A times positive A. Negative A square. Very good. Then, if that's the case, you say Laplace transform of what? Sin of AT. This is equal to what? Is equal to A over S square. AS minus AS. AS minus AS. 0, right? So we will remain with S square minus what? A square minus what? A square. This is the final formula. This is the general formula of Laplace transforms of 40 sin of A t. Did you understand? Listen. We call them formal teachers in classes. They write this formula. They just give you formulas, a number of formulas of Laplace transform. But I want to tell you that I have seen this question. It has been asked in a number of exams. Show that Laplace transform of sin of AT is equal to A over S square minus A square. Not to use, sure. Are we together? Yes. Did you understand? Yes. Okay, right. So now, that is Laplace transform. This is number 2. I believe you have understood. Remember that most parameters or most variables, independent and dependent variables of engineering, they vary with respect to time. So then we have what? Laplace transform of conch of, let's say, AT. Say conch of AT. Say conch of AT. Remember this formula because we will use it to solve different engineering problems and mathematical problems. So Laplace transforms of conch of AT. Stop writing. So we are focusing on derivation. Derivation of Laplace transform of conch of AT. We follow just 4 steps. The first step, we say that recall the hyperbolic function of conch of x in mathematics. So conch of x is equal to what? Can you write the formula for your neighbor? Write the formula of conch of x to your neighbor. What you remember. Just write what you remember or what you think. Write to your neighbor on the rough part. Write to your neighbor on the rough part. This is my formula of conch of x. Do you appreciate me or do you criticize me? Just write whatever you think. It's good to try. To try outside of the exam rather than to try in exam. So show your neighbor. Show your neighbor. Yes, show your neighbor what you have written. Don't ask your neighbor to explain it in detail. Okay, well, good try. Tell your neighbor congratulations. Tell your neighbor congratulations even if your neighbor is unhappy. Congratulations. So conch of x, the mathematical formula is e of x plus e power negative x over 2. That is. So you can correct. You can mark what you have written. If it is true or it's nearly true. That's the goodness of higher learning. You can answer the question and mark for yourself. And always you'll be writing 100. Why it's 0? Well, so with context of engineering, we change this function on left hand side and we change something of this function right hand side, right? For that case, we say that we have consi of AT, right? This is equal to what, ladies and gentlemen? Hello? If you have consi of AT is equal to what? Say it loudly. A power? This is not minus, ladies and gentlemen, negative. It's negative. It's not what? But kibongo bongo, we call it what? Minus. Then, is that the case? This becomes our first what? Question. Okay? We got the second step. The second step is what? These are the formulas or derivation that you don't need to claim them. You just need to understand them, then you continue your life. The second step, we say apply what? Physics. Apply Laplace to both sides of equation 1. Then we apply Laplace transform of consi of AT. This is equal to what? Laplace transform of e power AT plus e power negative AT over 2. Okay? I said stop writing. Then, if that the case, we say that we can take a half out of the bracket. Okay? So if we take a half out of the bracket, we have a half, open the curly bracket, then have Laplace transform of 40 of e power AT plus e power negative AT. Okay? Class, is it okay? Yes. Well, then now we are substituting Laplace into the bracket. Then have a half. Then have Laplace transform of e power AT. Then have what? Plus Laplace transforms of e power negative AT. Okay? So now let us substitute 2 into the bracket. So for that case, you say Laplace transform of consi of AT. This is equal to what? This is equal to a half Laplace transform of EAT, then plus Laplace transform of e power negative AT. A half. Thank you. Okay? Okay? Is it okay? Yes. Yeah, so this will be our equation 2. Right up that part. Did you understand? Yes. Do you enjoy mathematics? Ask your neighbor. Do you enjoy Laplace transform? Yes. Your neighbor say yes. Yeah. Good. Okay. So let us continue. Once we are here, we have simplified our equation. Previously, we are dealing with Laplace transforms of a little complicated function, but now we have simpler exponential function. The next step, which is the third step, we say that what? Recall. Recall what? Recall, recall Laplace transform of 40 e power 80. This is 1 over s minus a. And this will be equation 3. Do you remember that? A Laplace transforms of e power negative 80 is equal to 1 over s plus a. This is equation 4. Okay? Next step, the first step, substitute. Substitute what? A, question 3, and A, question 4. into what? Equation. Okay? Hello? Madam, make sure that you take care of that neighbor. So if you substitute on left hand side, we have Laplace transform of what? Conchi of what? 80 is equal to what? A half 1 over plus or minus plus okay, is it okay? Plus, thank you. Do you see that? If you have been writing, you could write errors. Then next, what do you say? Well, then we say that let us take 1 over 2 out and find the LCM. Tell your neighbor the LCM there. What's the LCM? Open bracket, S minus A, close bracket, times S plus A, close bracket. Okay? Then this LCM divided by this. Hello, madam. What did I say? The S minus A times S plus A divided by S minus A. S plus A, right? S plus A times 1. S plus A. So we'll have S plus A, right? Then plus S minus A times S plus A divided by S plus A. S minus A times 1. S minus A. Right? Right, class? Laplace transforms of Conchi of 80. This is equal to what? A half. Denominator is what? S minus A, S plus A. S plus S. S square. S to S. 2S. A minus A. 0. Then what do you have? We're going to have what? A half 2S over what? S minus A, S plus A. Okay? 2 and 2 cancel. So this is equal to what? S over S minus A times S plus A. Do you remember that S minus A times S plus A is equal to what? Hello? Hello? So this is equal to what? S over S square minus plus again. Let us prove. Why should we why do we want to claim while we can prove? Let us prove if it is minus or if it is minus or what? Or plus. Let us copy what you had there. Laplace transforms of 40. Conchi of 40. Conchi of 40 is equal to what? S over S minus A, S plus A. Right? This is equal to what? S. S times S. S square. S times A. Negative A times S. A negative A times A. Okay? So AS minus AS. Plus 0, eh? Are you sure? So therefore, Laplace transform of conjugate of 80 is equal to what? S over what? S square minus A square. That's the final form. So in that final formula, let me add some few things, then I will give you some time to copy. Listen. You should not claim that all the question will be asked, the constant will be A. The constant might be any letter. For instance, if you've been asked to write the Laplace transform of conjugate of BT, let's say this is equal to S over S square minus A square. Minus B square, sorry. Minus B. Okay? Okay? If you've been asked to find Laplace transforms of what? Conjugate of CT. This will be equal to S over S square minus C square. If you'll be asked maybe to find Laplace transform of what? Of conjugate of AX instead of 80, then nothing will change in the right on the right hand side. It will still be S over S square minus what? Minus what? A square. So if you change a constant, the formula on the right hand side will also change. If you change the variable from t to x, nothing will change on the right hand side. Class, are we together? Because the formula on the right hand side does not have variable t or variable x. That's why it doesn't change. The formula, it just has constant and s parameter. Class, are we together? Did you understand? Right. Write on your own hand. Mathematics is well comprehended by writing on your own hands. So once you have learned about how you can derive the formula of Laplace transforms of sinh of 80 and conjugate of 80, next you have to learn how to use those formula to solve problem. Stop writing. So then now let us move to example what? This will be example 1, 2, 3. Example 4. So example 4 is this one. Simple. Find Laplace transform. Laplace transform of the following functions. Of the following function. The first function, it is sinh of 60t. The next function is sinh of negative 3 over 4x. The next function, it is sinh of 0.7t. Next function, find Laplace transform of 40 conjugate of 3t. Then find Laplace transform of, you are welcome, madam, conjugate of negative 1.3 h. Then find also Laplace transform of what? Of 3 over 4. So these are the practice questions about that concept. I will not solve all of them. I'll just solve few, and then you'll solve yourself the rest, because mathematics is all about practice. Tell your neighbor, mathematics is all about practice. Stop writing. Solution. Solution. Let us start with the first example. Hello? Stop writing. Roman A, we have been asked to find Laplace. It means simply, we have been asked to find Laplace transform of 40 sin of 80. You are welcome. Sin of 60, not 80. Sin of 60, t. Okay? Then, if you've been asked to find Laplace transforms of sin of 60t, well, it's not difficult. We have just to say the first step. The first step, we say that recall. Recall what? The formula of what? Laplace transform of sin 80, the general formula of sin is equal to what? S or A over S square minus A square. That's all. For that case, Laplace transform of sin of 60t. This is equal to what? A, what the value of A? 6. For this question, A is equal to 6. So it will be 60 over S square minus 6 square. This will make it 60 over S square minus 36. So therefore, for Roman A, Laplace transform of sin of 60t, this is equal to what? 6 over S square minus 36. You will never find questions like this in exam, but you'll find question like this in exam are the part of the question. It's a part. It means that the questions might have 3 or 4 parts, right? Might have maybe 3 different types of function or 4 different types of function. So you need to know, or you need to know how you can find Laplace transform of each function separately, and then you come and combine them according to the question that you've been given. Are we together, class? Yes. Yeah. So we are going to combine the Laplace transforms of sin with Laplace transforms of exponential function, with Laplace transforms of trigonometrical function, with Laplace transforms of shifting property, etc., etc. So the question which will be given in exam, it's a collection of different concepts. But you have to split down and deal with each concept separately. If there is a sin, you have to split down and deal with it up to this point. Then you list another function, then you combine and simplify. Okay? Write down. Stop writing. Write down, then within a short time, stop writing. Listen, I want to solve a few examples, and then we'll be writing and trying. Because in these programs, we learn, we try, we practice. Say learn, try, practice. Yeah. So for the sin, which one you might think that is difficult? This one or this one? Which one do you guess that is difficult? This one or this one? Which one should I solve between this one and this one? Choose one. B, because it's a fraction. Good. So Roman B, we have been asked to find Laplace transform of sin of 40 negative 3 over 4x. Well, then we say that solution. So this is Roman B, solution. So solution, we say the first step, recall. Recall what? Recall the general formula of Laplace transform of 40 A sin of 40 80 is equal to what, class? X S minus. All right? Are we together? Yes. Then let us find Laplace transforms of sinh of negative 3 over 4 what x, sorry. So if it's x, here you have write x. Okay? If it is t, write t. So Laplace transforms of sinh of negative 3 over 4 of x. This one is equal to what? Is equal to negative 3 over 4 divided by s square minus negative 3 over 4 square. Why? Because a is equal to negative 3 over 4. Are we together? Next, what do you say? We have what? Negative 3 over 4. We have s square. Negative 3 over 4 times 2. Oh no. Negative 3 over 4 times negative 3 over 4. Negative times negative. Negative times negative. Yeah. It's simple. Just negative 3 times negative 3. What do you get? Positive what? 9. Then 4 times 4. What do you get? 16. Yes. You are teaching your kids about multiplication at home. You're a very good teacher at home. Counting number, memorizing the table. If your kid does not remember, you won't give him or her pocket money. Okay, so you can simplify also. Okay, so we have 1. Okay, then we have to deal with denominator first. Okay, so for this case, it will be negative 3 over 4. Then find LCM between 1 and 16. 16. 16 over 1. 16 times s square. 16 s square. 16 over 16. 1. 1 times 9. 9. Then you have 16 to go above. This one becomes numerator, is it? Eh? Anyway, so he said that we are going to have, let me just do this way. Negative 3 over 4 divided by 16 s square minus 9 over 16. Right? To divide fraction, you change the operation into multiplication. And you interchange numerator and denominator. Simple like that. Yeah, primary mathematics, fraction. So you have negative 3 over 4, right? Then you have what? Over what? 16 s square. That's why we used to say that this 16 becomes numerator. Okay? 4 by 4, 4. Then you have negative 3 times 4 over what? 16 s square minus what? This makes what? Negative 12 over 16 s square minus 9. Okay? So therefore, for Roman B, say therefore, Laplace transform of negative 3 over 4x of sinh, Laplace transform of sinh of negative 3 over 4x. Is it x or what? Yes, x. This is equal to what? This is equal to negative 12 over 16 s square minus 9. Okay, so try this one. Okay, so some physical students who have tried to find the sinh of 0.7t, almost all students have got a correct answer. I believe even for the online, you have also tried. Let me solve one question for conch. One question for conch. One question for conch. And then after solving one question for conch, then you can deal with others. Where is conch? So this one and this one. This is simple. Let us solve this one. Separating. So solution, we want to solve Roman A. we have to find Laplace transform of 40 conjugate of negative 1.3x. Then we will try this and this one. Okay? So how do we find conjugate of this function? Well, recall the general formula of Laplace transforms of conjugate of AT. This is equal to what? S over minus what? A square. Then, if that's the case, what do we say? Well, we have been given Laplace transforms of what? Conjugate of 40, negative 1.3x. This is equal to what? S over S. Unaona huyo mzee wa negative anakosa huyo anakumbuka sinshi. Negative 1.3. Okay? Then this is equal to what? S. You have to remember S. You should not claim that negative 1 over 3. No. And then in denominator we have what? S square. Minus what? Negative 1.3 times negative 1.3. No need of scientific calculator. Just 13 times 13. 169. You see? So if you have 1.3 times 1.3, you have 2 decimal places. So you have 1.649. But negative says negative. Negative 1.3 times negative 1.3. Positive, right? So this one is the one which will be positive. Positive what? Positive what class? 1.69. Then that's the response. So therefore, Laplace transform of conjugate of negative 1.3x, this is equal to S over S square minus 1.69. Okay? So try to solve Roman D and Roman F. Okay, so I believe that for the physical students that I have, all of them, they have solved the question example 4D and example 4F. And they found the correct answers. So I would like to appreciate them. I believe that every student have gone through these simple examples. I want just to remind you that don't expect a simple question like this in exam. These are just a part of the long questions of the Laplace transform. But it doesn't mean because you don't expect to find questions like this in exam that maybe you should not take care of them. You have to take care of them. Okay? Because once you miss this concept or you forgot, you cannot solve that question, or you can solve part of it. So, if that's the case, I would like to say that in this lecture 2, we are not going to cover Laplace transforms of trigonometric function. We'll cover Laplace transforms of trigonometric function in lecture 3 and lecture 4. So in the next lecture, I'm going to teach you about Laplace transforms of trigonometric function, and then I will teach you about Laplace transforms of double angle. So I would like to invite you in lecture 3, where that we have to move on or to carry on about this concept. And we'll just remind you quickly Laplace transforms of sinc of AT and Laplace transforms of cos of AT. So welcome in lecture 3 of Laplace transform, and make sure that you attend. In case you have a question or a challenge, let me know in the comment section, or let me know just through any means of communication. So I would like to congratulate you. Congratulations, student. Did you understand? Yes. So if you have understood, congratulations for coming and learning, trying, practicing, enjoying, and understanding mathematics. Congratulations. So I have always a tradition of appreciating my students whenever they do a work or whenever I teach them and they understand. I always appreciate. I don't know if my students appreciate me. I cannot talk about them, but myself, I have to talk about myself. So if that's the case, we have to enjoy mathematics. It's queen of engineering. It's an enjoyable subject. So now it's time I want to congratulate you. And yourself, you have to congratulate yourself. Because in community, people are always disagreeers. 1, 2, 3. Hongera. Imara. Wow. Thank you very much. May God bless you. See you in the next lecture. Bye-bye.